All right, welcome back for our final installment for 4.5. This is going to be example 4. What we've covered already, we've identified direct variations from equations. We've identified direct variations from ordered pairs. That was example 2. We solved some direct variation equations. We were given information and asked to solve for missing information, and we did that yesterday. And now, what we're going to be doing today is we're graphing. So we're going to graph direct variations, and they're going to give us a situation. And what I'm going to need you to do is be able to recognize that this is a direct variation situation. Now, we know it's a direct variation situation because they tell us that in example 4, they say right beside it, graphing direct variations. So we already know, they kind of tip their hand on that to us. All right, let me read the situation to you. The three-toed sloth is an extremely slow animal. On the ground, it travels at a speed of about 6 feet per minute. Write a direct variation equation for the distance y a sloth will travel in X minutes. And then we're going to graph it. So they're telling us some information. They gave us his rate of speed. Okay, now let me give you a really big hint. This is going to help you so much with direct variation and even in just regular old linear equations. If you're given a rate of speed, any kind of rate, it could be feet per minute, dollars per hour, dollars per second, whatever it is. If it's a rate, something per something, that's a rate, and that's your slope. That's always going to be your slope. So I just want to throw that out at you and make sure you know that's just a little bonus, a little extra information for you to know. Okay? Now, we also want to focus on the variables that they are wanting us to use in our equation. So in this case, distance is y and x means minutes. Okay? So we want to figure out an equation where distance is y. We want to be able to calculate distance, so y equals, and then doing something to the x. There's a number that's going to be involved with the x, okay? So can you remember, this is going to be yet another bonus opportunity. Oh, you are so lucky. Good for you, okay? So let's do a little squiggle down the side of your paper. Actually, do it in the white part. I can't do it in the white part because on the board I don't have a white part. So do it outside of your graph. On the bonus, can you think of an equation that uses distance, time, because time in our example is minutes, and distance is y, minutes is x in this particular, and they gave us rate. What is that all about? Can you think of another equation, another application of this type of problem? So that I'm just going to throw that out at you. If you know that application, write that equation somewhere in the white space in the margin of your notes, okay? And then put bonus near it so I can remember that I told you that it would be a bonus in class the next day, okay? So let's get back to writing our equation. What we want to do is we want to use the 6 feet per minute. And we know that every minute that goes by, this creature is going to go 6 feet. Okay? So if you're having a hard time coming up with the equation, you're like, I don't have a clue, Mrs. Thompson. This is just over my head. I don't know what to do and what you want me to write. Then let's make a table. Okay? I'm going to do a little XY table. And remember, X means minutes. Okay? I'll put min off to the side. And then y is distance, okay? That's going to be in feet. And so let's just do a couple points. I'm going to do 3 points, okay? So if the sloth has gone for a minute, how far did it go? And if you said, oh, it went 6 feet, because remember, the problem said it goes 6 feet per minute. So then it's 2 minutes have elapsed. How far did that sloth go? You're like, oh, it went then total of 12 feet. You're right. And let's 3 minutes have passed. How far did it go? Oh, it's gone 18 feet. Okay. Now, work backwards. Use the table to help you figure out what did you do to x to get y. If you say multiply by 6, you're exactly right. That's your equation. So if you couldn't come up with it first, then make your table and work backwards. Nothing wrong with that. No shame in that, okay? Sometimes I have to work backwards myself. It's not a big deal. Now, I am going to erase that bonus stuff. You don't erase the bonus stuff. I just need the room. And we're going to make a graph. Now, I already did the table because we were working backwards a little bit. And let's just focus on 3 points. Look at your distances. That's your y-axis. So it's going to be as high as 18. So as you plan this out, and notice too, just on an aside, all your numbers are positive. Now think about it. Are you ever going to have negative numbers of minutes? You don't need the negative side of the x-axis. Are you ever going to have negative distance? That's right. You're not going to need the negative side of the y-axis. This is definitely going to be a quadrant 1 graph. Everything is positive, so make it a quadrant 1 graph. That's what makes sense. Label your graph, okay? So x-axis, we're going to call number of minutes, and we will go by ones, okay? That's fine. And feel free to put your numbers there. I normally would write those underneath, but I wrote the word minutes and it kind of blocked my way. And then we're going to call the y-axis distance. And of course, that's going to be in feet because the problem said that the sloth is going 6 feet every minute. So I already know what the distance and what the measurement is. It's in feet. And now think carefully how you want to do this. I would not recommend going by 1. So your options are you could go by 2s, 3s, even 6s. Whatever works for you, okay? Let me count it out. Let's see what 2s would look like. So we've got 2, 4, 6, 8, 10, 12, 14, 16. Yeah, I've got enough room. So if I go by 2s, I can get all the way up here to 18 pretty easily. Yeah, there we go. So I'm just showing the increments I'm going by, and you can actually show every number. You don't have to skip or anything. Just don't go by ones. Whatever you do, please don't go by ones. I think that would just be a really tall graph, and I don't think anybody has time for that. So let's start graphing. We've got 1, 6. There it is. 2, 12. And then 3, 18. And there you go. We have definitely a straight line. Now, I told you in the first example, when I was introducing the concept of direct variation, I told you that these types of lines always go through the origin, okay? So does it this time? Well, let's plug it in. Let's plug in a 0. If x is 0, what's 6 times 0? You're right, that's 0. So yeah, it definitely goes through the origin. So there you go. There's our line. So 0 minutes have gone by. The sloth has not traveled any distance. After 1 minute, he's gone 6. 2 minutes, he's gone 12. 3 minutes, he's gone 18. And there's your graph. Okay, so just make sure you've labeled each axis, okay? Do a good job in labeling, and of course, be careful choosing the type of numbers, what increments you want to go by. If you have any further questions, bring those to class tomorrow, and I'll be happy to answer them.